Hello and welcome to another GCSE Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on Boolean logic. Boolean logic is understanding the logic with which Boolean expressions are evaluated. The Boolean expressions this course covers are not, and, or, and XOR. Each one has its own logic gate symbol, truth table, and Boolean expression symbol that you need to learn. So let's take a look at them more closely. The AND logic gate, also known as conjunction, takes two inputs and outputs true if both inputs are true and false in all other cases. The logic symbol for the AND logic gate looks like an extended D, as you can see here at the top. The logic notation uses the caret, which looks like an upside down V to represent AND. The truth table for any particular logic gate shows all outputs for each possible combination of inputs. So for our AND gate, if input A is true and input B is true, then the output of A and B is also true. If A is true and B is false, then the output is false. If A is false and B is true, then the output is false. And if A is false and B is false, the output is still false. The OR logic gate, also known as disjunction, accepts two inputs and outputs true if either input is true, and false only when both inputs are false. The logic notation for OR is a capital V. To differentiate your OR gate from your AND gate, make sure that it has a pronounced curved back and is slightly pointier at the front. As you can see in our truth table, if input A is true and input B is true, the output will be true. If input A is true and B is false, the output is still true. If input A is false and B is true, then the output is still true. And only when input A is false and input B is false is the output false. The NOT logic gate takes just a single input and outputs the opposite. So if it receives true, it outputs false. If it receives false, it outputs true. As you can see by the diagram here, the logic gate for negation is a triangle with a small circle on the top. The notation used for negation is the NOT symbol, which looks like this one here. The XOR, or exclusive OR, also known as exclusive disjunction, takes two inputs and outputs true if the inputs differ and false if they are both the same. The logic gate symbol for XOR looks like the OR gate, but with an additional line at the back side on the input side. The notation for XOR is a V with a line underneath it. As you can see from our truth table here, if the input for A is true and input B is true, then the output is false because they are both the same. If A is true and B is false, then the output is true. If A is false and B is true, then the output is true. If A is false and B is false, then the output is also false because they are both the same again. Logic circuits are made up of multiple inputs and multiple logic gates. The output of each gate will be represented in a truth table when we try and represent our logic circuit. So this basic logic circuit here, we start by considering all the possible inputs for input A, B and C. So there'll be 2 to the 3 or 8 different combinations of inputs that we can have. The first thing we check is the result of A or B, and we can see that 0 and 0 gives us 0, 0 and 0 gives us 0, 0 and 1 gives us 1, 0 and 1 gives us 1, 1 and 0 gives us 1, 1 and 0 gives us 1, 1 and 1 gives us 1, and 1 and 1 gives us 1. Now we can take these values that we've found and use those in an AND with the values from input C. So as we go down, 0 and 0 is 0, 1 and 0 is 0, 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1. So we get to our final output from our logic circuit by combining the two gates. This can be represented by the logic statement that output Q is equal to A or B and C. The brackets are important because the A or B has to take place first. That brings us to the end of this video on Boolean logic. Join me in the next video when I'll be looking at programming languages. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.